The last proof technique we want to talk about before we do induction much later in the semester is proof by cases. Proof by cases is not really an entirely new technique. You've already been doing cases in various other forms in mathematics. For example, when you define a piecewise function, then you are breaking essentially the function into two cases. If x is less than 0, then the function looks like x. If x is bigger than or equal to 0, then the function looks like x minus 1. Similarly, if you have a quadratic and you have something like this, then the next step from here is to break it into two cases. And then you typically will do the first case separately and then the second case separately. And that's exactly what proof by cases is doing, except in the context of proofs. So it's not a new idea, just a different application of the same concept. So I want to show that the product n times n plus 1 is even for every natural number n. The way I would attempt this is, I have no idea how to do this. I just something about n plus 1. I don't know what it has to do with evenness. So I'll just play around with numbers and see what happens. So if I do 0 times 0 plus 1, I get it is even because of the first part. Now let's do 1 times 1 plus 1. Now here I'm getting evenness because of 1 plus 1. Now if I go to next one, I'll get 2 times 2 plus 1, and I get evenness because of this. And 3 times 3 plus 1, and I get evenness because of this. So if you notice, what is happening is that when n is even, then the first of the product, the first part becomes even. When n is odd, of the product, the second part becomes even. So the reason is dependent on whether n is odd or whether n is even. So I'll just make two cases, whether n is odd or n is even, and then do the two cases separately. Suppose n is odd. Now, because n is odd, I can write n as 2 times k minus 1 for some natural number k. So 1 becomes 2k minus 1 times 2k minus 1 plus 1. That is 2k minus 1 times 2k. And I will just put the 2 in the front. And because this is a multiple of 2, actually not yet. So what I've done is I've proven this case, not the whole thing, but just one part of it. Now I'll prove the other case. And I don't have to do anything more. Here I see it's a multiple of 2. So now I've proven the statement for both the cases. And because every integer is either even or odd, I'm done. And this completes the proof. So that's it. Proof by cases is probably the easiest of all the techniques. It's just break the problem into cases and then attack each problem separately.